So we are starting equilibrium this week. Equilibrium in 2 dimensions. We are going to discuss about equilibrium in 3 dimensions at the end of the course. But we need everything that we have learned so far to do this one. So are you guys okay, or do you want me to summarize the things that we have done so far? Finding the resultant force, finding the resultant moment. Are you guys okay with that?
Yeah, I am, I think.
Yeah, I think so.
I'm also all right with it.
Okay, so
If not, I can fake it.
when we start doing questions, if you feel like you need like summarize or revise things, let me know. Okay, so I'm skipping all this one. So because the summary part I'm going to skip because you guys are okay. What is moment and direction, all this stuff I'm going to skip. So these ones are okay. Okay, we'll start equilibrium. So equilibrium is in the equilibrium topic, we are going to find out concept of equilibrium. What do we mean by equilibrium? And also how to find the unknown forces when something is in equilibrium. In our case, mostly the things that we are designing, maybe a bridge, road, or building, they are stationary things. So equilibrium should be there. So equilibrium means with the Newton's definition for equilibrium, equilibrium is something stationary or else something moving with a constant velocity. So that means the force is equals to 0. So sum of the forces. So that means it can move, but there can't be an acceleration. So acceleration should be F equals ma, that you know that equation. So acceleration is 0, but it can be something moving with a constant velocity, or else it can be stationary. The other thing is, it's not only the force. We can't say just by looking at the force, we can't say something is in equilibrium, because for example, we discussed last week, moment, for example, if you have 100 newtons like this and 100 newtons like this, if you consider the sum of the forces, it is 0, because upward 100, downward 100, so forces will cancel out and the resultant force is 0. However, this is not in equilibrium. This is rotating, so you can see there is a moment, there is a couple moment. So it's like steering wheel. You are holding the steering wheel from left and the right sides, and you just push the left hand to the up and pushing the right hand to the down. So it's not linearly moving to right or left or up or down, but it is rotating. So if something is equilibrium, the forces should be equals to 0. Sum of the forces should be equals to 0. And also the sum of the moment about any point should be equals to 0. So these are the 2 conditions of equilibrium. And also, when you look at the forces, we know now we can divide forces into 2 perpendicular directions. So forces in the x direction, when you consider all the x components together, when you add all the x components together, that should be equals to 0. When we consider all the y components together, it should be also equals to 0. So you can divide the force requirement of the force to 2 categories: x direction forces and y direction forces. So if something is in equilibrium, these 3 conditions need to be satisfied. Moment about any point should be equals to 0. Sum of the forces in the x direction should be equals to 0. Sum of the forces in the y direction should be equals to 0. So that's what we are going to do today. And when you consider now, why I told you that we need everything that we have learned so far, because in the first week, we discussed how to find the forces, how to find the sum of the forces, resultant force. So now we are going to apply that theory, that knowledge here. And also last week, week 2, we discussed how to find the moment correctly. So again, now we are going to find the moments of different forces created by different forces, and we need to equal them to 0 to find any unknown forces. So that's what we are going to do. Is everything, are you guys okay with that? How are you, Lou? We just started, you didn't miss much, but I'll explain this again and again when we do questions, okay?
Yeah, thanks.
Any question from others? I'll move on. So I already discussed this one. So equilibrium means at rest or something moving with a constant velocity. So transitional equilibrium means forces should be equals to 0. As I have mentioned, sum of the forces should be equals to 0 when we consider sum of the forces, x direction forces and the y direction forces both should be equals to 0. And the rotational equilibrium means moment, sum of the moments. Moment is force times the perpendicular distance, and moment again a vector. So when we are adding moment, we need to consider whether it is a clockwise moment or counterclockwise moment. We discussed last week, we consider counterclockwise positive and clockwise negative. Otherwise, you need to mention which one you consider as positive or negative. Similarly, like, we consider x direction positive this way, y direction positive this way, and similarly we consider counterclockwise as positive. So that's the sign convention. And the moment is force times the perpendicular distance. So we need to know how to find the perpendicular distance. When we do a question, I'll summarize whatever we have done last week. I think not most of you were in the first class. Okay, so we have to, so moment, this rotational equilibrium need to be considered only when you have a rigid body. When you have a particle model, when you can consider your forces, your system of forces as a particle going through a single point, when all the forces are going through a single point, you don't have to consider the moment equation. You can just apply this and you will be able to solve questions. But if there is a rigid body, that means forces are not going through a single point. For example, this one, let's say we have this force like this force. So these are the forces. Now, when you extend the line of action of the forces, if you see that it is not going through a single point, say they are intercepting at different points. So in that case, you need to consider the moment as well. Forces going through single point means, so when you consider this force, so there can be many forces, but if all the forces, when you extend the line of action of the force, if they are intercepting at a single point, then we only consider the translational equilibrium. It's okay to consider the moment, but it is taking time, wasting your time. This one is not needed when everything is going through a single point, because it's obviously the moment about that point is 0. Okay, so particle, as I have mentioned, you don't need to remember all this. If all the forces are going through a single point, you can consider it as a particle. Okay, so this is a particle model question because all three forces are going through a single point. So it's easy to do a question than explaining the theory just so I'll explain you how to do these equilibrium questions in this one. In the diagram below, F1, F2, F3 are three forces acting on a particle A, remains at the rest under the action of three forces. So when they say remain at rest, we should know that means it is in equilibrium. So all the forces in the x direction is equals to 0. All the forces in y direction is equals to 0 as well. So they are asking us to sketch the vector diagram, vector addition diagram. So we learned that first week. So let's do this. So when you are drawing vector diagram, as this system, this particle is in equilibrium, your vector diagram, what can you say about the shape of the vector diagram? What this means? Rest means the resultant force is 0. So that means your vector diagram should be what? What is the shape?
Is that a closed shape?
It is a closed shape, yes. So start to end is 0 because it is no resultant force. So let's draw this. So they are first asking us to draw it. So you can start at any force. So I'm going to start with the given F3. So it is starting like this. This is my start. And we need to go this way. So that is 200 root 2 newtons. Now you can either draw F1 or F2. If you draw F1, F1 is making 135 degrees like this, see? So this is 135 and it is going F1. We don't know F1. We need to find F1. And then F2 is making from the horizontal axis again 130 like this, see? So that is 130 and I need to finish this at this point because the resultant is 0. So it should end and the start should be at the same point. Now this is the vector diagram. They're asking us to find the vector diagram and this is our F2. So if you draw like this, that gives us the vector diagram. Use the diagram to determine the magnitude and the direction of the forces F1 and F2. So we can apply sine rule or cosine rule. I think here we can apply the sine rule, isn't it? Because we need to find sine rule says what? So I'm gonna just give some values for here. So this is 135. This angle should be 180 minus 135. Do you agree with that?
Yes.
Okay, so I find that angle. Let me take my calculator. So 180 minus 135. So this is just a 45 degrees. So just write this as 45. This is 45 degrees. If that is 45, this also 45. So we can find the other angle as well. This one here, it should be 135 minus 45. If you don't understand, let me know. Okay, so this is a 90-degree angle. And the three angles, if I add three angles, it should be 180 because this is a triangle. So 90 plus 45 plus, 90 plus 45 is 135. If we minus that from 180, that will be 45. So this is 45 degrees. Now, anyone have any issues up to here? Now you can apply the sine rule. You can work on you. If you understood, you don't need to wait for me. So this force divided by 45. So I can write it as F2 divided by sine 45 is equals to, I can write another one like this. So this force divided by 90. So 200 root 2 divided by sine 90. Sine 90 is 1. And then I can say this F1 force divided by 45. So F1 divided by sine 45. So this is sine rule. Guys, sine rule can be applied to any triangle. It's okay if it is a right angle triangle. This is a right angle triangle. So it's true for right angle triangle as well. So we can say F2 is equals to 200 root 2 sine 45 because sine 90 is 1. And F1 is equals to again 200 root 2 sine sine 45. So both the same. So you can find the answer now. 200 times root 2 times sine 45. So that is 200. So this one is 200 newtons and this one is 200 newtons as well. Are you okay with this? Any question?
Nope, I'm all right, thank you.
Okay, there is another method. Calculate the vertical and horizontal components of the forces and use these to determine the magnitude and the direction of the force upon. Okay, so first they're asking us to use the vector diagram and solve this, and then they're asking us to use the component method to do this. So vector diagram method is fine. And I want to show you another way of using the vector diagram. Without drawing the triangle, you can do it in a different way. So this angle is 90 degrees. Do you agree? Because when you add 135, and whatever the angle here, it should be 360. So this should be 90 degrees. Without drawing the vector diagram, you can apply sine rule for this diagram as it is. So how do we do it is, so this force here, 200 root 2 divided by sine 90. Sine 90 means this one. So this force divided by the opposite angle. And this force divided by this angle is equals to this force divided by this angle. So you can do that as well. You still get the same mass. So you can say F1 divided by sine 135 is equals to F2 divided by sine 135. You can draw the triangle and do it, or else, because here they are asking you to draw the triangle, so you need to draw it. But in a question, if they are not specifically asking for you to draw the diagram, you can do it like this. So you still, if you put these numbers, you still get the same answer. Any question? Now let's see the vector component method. So in the component method, so that covers, if you have forgotten the week one, how to draw the vector diagram, how to apply the sine rule, cosine rule, we'll have it in a different question. So it is revising your week one. The component method, what we do is we divide the vectors into x, y directions. So if you take F1, so this is F1. So we can divide F1 into two components. So this angle, we found this angle as 45 degrees. We found it previously as well, 180 minus 135. So now if you divide F1 into two components like this, x component will be F1 cos 45. I told you when you come towards the known side, it is cos, and this will be F1 sine 45. This question is fine, sine 45 and cos 45, both the same, but if it is different, you need to remember to put the correct one, sine or cos. And this is F1 sine 45. Okay, and both are positive because upward and towards the right. So then we'll do, so we divided F1 into two components. Similarly, I'll let you to do another question, okay? I'll explain the method here and I'll let you to do another question by yourself, and time, I'll give you time. So now F2, if you consider F2, you can divide F2 again into two components like this, and this is again 45. So we can write F2 cos 45 towards the positive x and F2 sine 45 towards the negative y. So your y component is a negative this time, which is F2 sine 45. And your x component for F2 is F2 cos 45, which is positive. And also we have F3. If you look at F3 is y component is 0 because it's towards the negative x direction. So x component is negative 200 root 2. So first, if you use the component method, we normally use component method when we have more than 3 forces, because triangle, making a vector triangle is easy, but if it is a vector polygon with many number of sides, it is hard for us to solve using the trigonometric relationship. So in that case, we use component method because it is much easier. Now, if you find the sum of the x component, if you add all these together, as this particle is in equilibrium, it should be equals to 0. So when you add all these together, you can say F1 cos 45 plus F2 cos 45 is equals to, minus 200 and root 2 is equals to 0. So that is one equation. Then again, you can say, if you add all the y components together, that means f1 sine 45 minus f2 sine 45 is equals to 0. So this is your second equation. You have two simultaneous equations. You have two unknowns, which are f1 and f2. So you should be able to solve the two simultaneous equations and find the unknowns. This is an easy question because here you can say f1 equals to f2. Sine is cancelling out because sine, if you divide everything by sine 45 will cancel out. And f1 is equal to f2. So you can use that relationship. F1 equals F2. So you can, instead of writing F2 here, you can write F1 and you can find F1 by solving this equation. You will still get the same answer. After you find the F1, that is equals to F2 as well. Is it clear? Any question? Do you need time to write down anything?
No, it's all recorded.
I put all the PDF files of these ones in view so you can find the PDF ones as well. So this one we already did. So, okay. Now the rigid body. In the rigid body, I told you we need to consider the rotational equilibrium as well. You need to find the moment about any point and you have to make it to 0. So what is a rigid body? These all are true, but you don't need to remember all this. When the forces are not going through a single point, then you have to consider it as a rigid body. When the forces are not, the line of action of the forces are not intercepting at a certain point, that means it's a rigid body and you need to consider the rotational equilibrium as well. Okay, let's do a question. Yeah, this part I already explained. Okay, when you do a rigid body problem, first you need to draw the free body diagram. So free body diagram means you consider a part of your structure. So for example, if you want to draw the free body diagram of this beam, this is a beam. So you separate the beam. So this is the beam. So I just draw beam. Now you need to consider all the forces acting on the beam. So we have this 20 Newton force and also there are two supports here. So these two supports are giving some forces. So you need to put those as well. So this we call the free body diagram. So how do we draw it? We separate the part of the structure that you need to consider. It doesn't have to be the whole beam. Later on, when we consider the internal forces, we can even consider a part of the beam. So for the time being, we only consider, like, we don't have to go to that depth. You consider the beam that you need to analyze and you separate it and apply all the forces acting on the beam. So that we call the free body diagram. Free body diagrams are very important because without that, we can't solve this problem. Now, free body diagram technique is one of the most important techniques we will learn in solving mechanics problems. By applying the free body technique, we can separate any part of an object structure to determine the action and reaction of the free body. So that's what we are going to do. So we separate the beam, we apply all the forces, and that we call the free body diagram. Now, we have three kinds of supports. Any structure, after learning this, you can look at all your bridges and roads and buildings and whatever you have, and you can figure out what kind of supports they have. So three supports are these three. So you can have roller supports. So you see that here. So this one is a roller support on a bridge. I think these two are in NSW. I think I can't remember which ones are there. So roller support is something like this, and also
Second
you
one's
can
a
see.
harbour bridge.
Is it okay? So this one is a pin support, and these are fixed supports. So now when we just consider the span of the bridge, or else maybe a beam like this, we need to replace these supports by forces. So if you look at the roller support, you can see roller support is only preventing movement in this direction. Do you agree with me? It's led the beam or the object to move in this direction. It's not resisting the x direction movement. It's only resisting y direction movements, isn't it? And also any rotation can happen about the pin. So any rotations can happen. X direction, it can roll along the x direction. It's only prevent moving in the y direction. Do you agree with me? So when you are replacing a roller support, you can replace it with just one support like this. One reaction like this. So when you think about the pin is you can keep your two hands together and think like you have a pin. You pin the two arms together. So what will happen now? What movements are possible and what movements are not possible?
Circular, because it can kind of pivot,
Yes. So
but it can't
rotate.
go left and right though.
Yeah, right and upward or right, left. It can't move in the upward or downward direction or right or the left, but it can rotate. So when you are replacing it, it's giving it prevent two supports, two reactions like this. It doesn't let the structure to move in the x direction, and also it doesn't let the structure to move in the y direction, but it let the structure to rotate about that point. Fixed support is not allowing to move, allowing for any movement. Can't rotate, can't go in the x direction, can't go in the y direction. So when you are replacing a fixed support, you need to replace it with x direction force, y direction force, and a moment. So you need to remember this because we are going to use this for like throughout. So roller, just one support. Pin, two supports, x and y. Fixed, three reactions, three unknowns, moment, y force, x force. And the roller, depending on what kind of roller you have, this force can be in the x direction or y direction. For example, you have a beam like this. So in that way, if you consider the reaction force, it's like this. So depending on the roller, the direction of the roller, this reaction can be in the horizontal direction, or it can be in the vertical direction. You need to figure it out just by looking at the diagram. Are we all good? Any question? Yeah, I assume that you don't have any questions. Okay, so here what is happening? Here, what do we have here? It's a pin. This is a roller. Roller, we use the rocker as well. For roller, in some questions they say rocker. Rocker will show you not like a circle, half of a circle, and it is like a rocking thing. Still, it is like a roller support. So if I replace the A, I can just say pin support. So and the other one is a roller support. So I can replace it like this. No. When we know the result, the directions, it's really easy. So roller support, you only have one unknown force. For the pin support, you have two unknown force. So when we are naming them, we are naming in a way that it is easier for us to recognize. So this is the point A. So we say this one is AY and this one is AX and this one is BY because that is in B. So that's how we are going to name them throughout. So it will be easier for us to recognize which one is what. Okay. Okay, so this is a fixed support. Okay, so how do you draw the free body diagram for this one? Can you please draw the free body diagram for this one? Free body diagram means you just take the beam out and you put all the forces acting on the beam. So what are the forces acting on the beam? So you have 1,200 newtons acting on here with 2 meters, and this is a fixed support. Yes, so you have a x force and a y force and also moment, unknown moment. So this is what we call the free body diagram of this one. Are we good?
Yep, all good.
So here they say A is a rocker. Rocker means like this. And B is a pin. So B should have 2 unknown forces, like two unknown forces actually. B should have 2 unknown forces like this. B1, Bx. B is a pin. Okay, now the next one. How about this one? What do you have here?
A pin, a piv.
A pin, so it should have 2 unknown forces in the x direction and y direction. So if you draw like this, that is the free body diagram for this one. And at B, what do we have at B? It's a roller, so it only preventing the y direction forces. So this is your free body diagram. So you have taken the beam out and you have taken the supports out. So you have just the beam and the forces acting on the beam. Okay, now so I hope you understand this. We'll do a question now. So steps are, first we need to identify the supports, whether it is a pin support, roller support, or a fixed support. Then we draw the free body diagram and then we apply the equilibrium conditions. So what are the equilibrium conditions? All the forces in y direction should be equal to 0. All the forces in the x direction should be equal to 0. Sum of the moments equals to 0 at about any point. Okay, so let's start with this. Can I give you a few minutes for you to draw the free body diagram, please? Free body diagram for the whole part. So you need to consider all of this. This is your part of the free body diagram. So this one, you draw that. So I draw this one. You can draw the other members, but if you draw like this, that's also fine. So how can I give you a few minutes for you to try, please? So what do you have at A?
Unknown X, unknown Y, and a moment.
Why the moment is it a pin or a fix?
Because it's a pin.
It is a pin. So pin let the structure to rotate. Am I right?
Mm-hmm.
So we don't need to draw the moment. How about the B? What
Right.
do you have in the B?
Got to be the same thing because it's another pin.
So don't you see these rollers at the bottom?
Oh, sorry, they're tiny.
Yes, so that is a roller. So you have just one force. So this is By. Okay, what else we need to draw? So we separate the frame, the truss, and yeah, do I have to do, have I finished or do I have to do anything else? I need to draw all the forces acting on the structure, isn't it? So we have this and this as well. So I need to draw this as 5 kilonewtons and also 10 kilonewtons at 2 meters from here and 4 meters from here. Are we good? Any question? Are you guys okay with the free body diagram?
It's all right.
Okay, so I'm not going to use my diagram. I'm using this one because my one is ugly. So this is what we have. Now we have done the first step, which is drawing the free body diagram. And also the second step, first step is identifying the supports. We found the supports which is a pin at A and roller at B, and we replace them by forces, and we have separated the structure and we have put all the forces. So this is our free body diagram. Now the next one is for us to apply the conditions of equilibrium. So this is a rigid body. So that means we need to use all three things. So sum of the forces in x direction should be equals to 0. Sum of the forces in the y direction should be equals to 0. And the moment about any point should be equals to 0. Sum of the moments. So now let's do it. We are going to apply everything that we have learned so far. So to find the x direction forces, what are the x direction forces we have? We have this one. And also this 5 kilonewtons. It is a slanted force. It is not in the x direction or the y direction, but it can be divided into two components like this. Do you agree with that? So this is 45. So this should be 45 and this should be 45 as well. So we can say this is 5 cos 45 and this is 5 sin 45. Agree? Now, if you consider all the forces in the x direction, what are the forces in the x direction? So we have this one and also this one. So when you add them together algebraically, considering the direction, so x direction this way positive. So we have ax plus 5 cos 45 should be equals to 0. Do you agree? So I can now find ax. Ax is equals to what? Negative 5 cos 45, which is, if you put that number in the calculator, 5 cos 45, which is 3.54 kilonewtons roughly. Okay, so we found one. Is that right? So that's we applied this condition. Sum of the forces in x direction should be equals to 0. So we added all the forces in the x direction and we made it to 0, equal that into 0, and we found an unknown force, which is ax. Now we consider all the forces in the y direction. If you don't understand, tell me, okay? Otherwise, I assume that you understood everything. So we have this force acting in the y direction, this force acting in the y direction, this one and this one, all four forces acting in the y direction. Do you agree? So how can we write it? Y direction is positive upward, so all the forces in the positive y direction. So we have ay, positive upward, arrow is upward, and minus 5 sine 45, because downward, the arrow is downward, and we have minus 10 and plus by is equals to 0. So this is the equation we get when we consider all the forces in the y direction. So we have two unknowns in this one, so we can't solve it as it is, but we can say, we can make it like, we can make the ay the subject, maybe ay. If you make the ay subject, that is equals to 10 plus 5 cos 45, sorry, 5 sin 40, 13 point. So you can say 13.54 minus by. So you can have a relationship between AY and BY like this. Is it clear? Any question? If you don't understand, tell me, I'll go through again. If you are okay, that's fine. Otherwise, I can go through again. Are you guys okay?
Yep,
That's
I'm
okay.
all right, thanks.
Now one more thing. So we have done this part as well. Y4. Now we are going to take the moment. Moment can be taken about any point. So when you are taking the moment, try to take the moment in a way it has, find the point where you have many unknowns. For example, if you consider point A, there are two unknowns. Normally we apply the moment equation first. You will realize why it is, because moment equation we can cancel out many unknown forces, because we can select a point where we have many unknowns and we can get rid of all these forces. So now if you consider AX is going through A and AY is going through A. Now if you take the moment about A, counterclockwise positive. So is AY making any moment about A? What is the moment created by AY? Moment is force times the perpendicular distance. So what is the force times the perpendicular distance for AY?
This is about A, correct?
Yes, about A.
Then it would be 0.
Yes,
because
so
it's
this one
going straight
doesn't
through.
any moment because that force is going through the point. So there is no perpendicular distance. Perpendicular distance is 0. Same with the AX, so it's not making any moment. How about now one by one? Take the moment one by one. The last week 2, we discussed one by one how to find the moment. So let's take first one, BY. So if you extend the line of action of the force of BY, and if you draw a perpendicular line from A, making a 90 degree, so that force BY times the perpendicular distance. So you need to find the perpendicular distance for this one, which is 4 plus 2, this one is 6 meters, and here is 6 cos 45, because this is 6, so the base of the triangle is 6 cos 45. So you can say 6 plus 6 cos 45 is the moment created by BY. And that moment is in the counterclockwise direction, so it is positive. See, the arrow is upward, so this one, if you push at B, it is rotating in the counterclockwise direction about A. The structure is rotating in the counterclockwise direction. Does that make sense? We'll do another question, okay? So we'll do a simple question to see whether I'll give you a simple question to do by yourself. Okay, now if you consider 10 perpendicular distance is this distance. So 10 times perpendicular distance will be 6 cos 45 plus 2 now, because this is 2. And it is, if you push it, this is going in the clockwise direction. So this is a negative moment. And we have two more forces actually. So we have 5 sine 45 force, which is this one here. So the perpendicular distance will be 4 cos 45, and it is making a clockwise moment, which is negative. If you consider this one here, 5 sine, cos 45, and it is making perpendicular distance of this. So again, it's a clockwise moment, so it's a negative 5 cos 45, and this is 4 sine 45. Now, when you add all these together, it should be equals to 0, and you can find the unknown BY. So that's the procedure. This is a hard question. Okay, so now if you understood this one, you can do simple questions. Let me do a simple question with you guys. So this one. So this, I put this in this. Let's do a simple question, all are like that. Let me see whether we have. Yes, so let's take a question from the tutorial because in the lecture part I have all the hard questions. We'll come back to this one. Okay, so can I ask you to find whether this one is okay. So this one. Yes, let's do this one. So can you find me the support reaction? Support reactions means you have a fixed support at A. So if you draw the free body diagram and if you put all the unknown forces, you will be like this. Am I right? Is that correct?
Mm-hmm.
Okay, now can you apply the equilibrium conditions? So what are the equilibrium conditions? Sum of the forces in x direction should be equals to 0. Sum of the forces in the y direction should be equals to 0. Sum of the moment about every point should be equals to 0. Apply these three conditions to your free body diagram and find me the three unknown forces, three support reactions, AY, AX, and MA. I'll give you a few minutes and I will do after you try by yourself. Okay, if you consider all the forces in the x direction, tell me what are the forces in the x direction? Do we have any force in the x direction?
No.
Yes, we have this one, AX. So AX, that's all we have. So AX is equals to 0. AX can't be any force, it should be 0. So we found one unknown. Am I right?
Yep.
What are the y direction forces we have? In the y direction, what are the forces we have?
1200 and AY.
Yes, AY is positive because upward, arrow is up, and 1200 is negative because arrow is down. So this should be equals to 0. So we can say AY is equals to 1200 newtons. We found another unknown. Am I right? Last one, we can consider moment about any point, and it is easy if you apply the moment about A because that will cancel out these two. These two won't come into our equation. So if we take the moment about A, so that will be MA is, I have put it in the clockwise direction. So this is a negative moment. MA is negative, because I have put it in the clockwise direction. Otherwise, if you want to consider clockwise positive, you can, but you need to mention it. Okay, so if you want to consider clockwise direction positive, you put it here. You have to show it. So this is my positive. You need to show that. So normally, as we take counterclockwise positive, I prefer to use that sign convention so that you will get used to it. So all the counterclockwise positive. So this is a negative MA because MA is in the clockwise direction. And 1200 is making a moment about A. How do we find it? We extend the line of action of the force and we draw a perpendicular line from the point where we are taking the moment about, and this distance 2 meters is the perpendicular distance. So I can write 1200 times 2. Now to find out whether it is clockwise or counterclockwise, what we do is we draw a circle around. Last week we discussed this. So if you consider the arrow, it is going about A in the clockwise direction. If you draw a circle, it is going in the clockwise direction. So this is also a negative. So that's all we have, 2 moments, and that should be equals to 0. So you can say MA is equals to negative 2400, isn't it? Newton meters. So these are the 3 unknowns. We found 3 unknowns. So it's okay to have the signs like this. So negative means we have put it in the clockwise direction, but our assumption. So these forces, we put the arrows as we want. So we didn't know the exact direction. AY also AY is a positive. So this arrow should be in the positive direction. This is right. But MA should be in the opposite direction. It should be going like this. And AX is a 0. So you can now say this one as 1200 and this force as 2400 Newton meters. So these are the two reactions. If you take the fixed support out, these are the support reactions. Support is providing these reaction forces to the beam. Is that make sense now? This is a very simple question. So I hope you are okay with this. Are we good? Can you try this one, please? I want you to do everything, okay? They're asking just to draw the support reactions, but I want you to find the support reaction. So you have A as a, A is a rocker and B is a pin. So if you draw the free body diagram, you just have one unknown here and you have 2 unknowns here. Do you agree? It's okay to put arrows in any direction, okay? If you are wrong, your answer will be, you can assume support reactions are upward or downward. Normally, we consider upward and towards the X, positive X. If it is wrong, we get a negative answer. So this is our free body diagram. Are you okay with the free body diagram? Are you all okay with free body diagram?
Yeah, I'm all right, thanks.
Okay. Now what is the next part? We need to apply the 3 conditions of equilibrium. Before applying 3 conditions of equilibrium, we may need to divide this force into 2 components because we have a slanted force here. So you can divide this into 2 components and ignore this. So this will be 600 sine 45 and this will be 600 cos 45. Okay. So now let's take one by one. Let's take the moment first. Moment, when you take the moment first, it is easier. So when you take the moment, I told you to select the point where you have mostly unknowns. So tell me, you have unknowns at A and B. So which point has more unknowns, A or B? Unknowns are AY, BY, and BX. So where we have more unknowns, at A or B?
At B.
At B. So we need to take the moment about B. It will be easier for us because then it will cancel the moment created by by and bx. So when we take the moment about in B, so this one doesn't make any moment, this one doesn't make any moment, this one doesn't make any moment because they are going through the point where we are taking the moment about. Now let's take one by one. So first take this one. If you extend the line of action of the force of 100, and if you draw a perpendicular line, this distance is 2. So we can say 100 times 2, and it is a clockwise moment or a counterclockwise moment.
Counterclockwise.
Counterclockwise, because your arrow is downward, so it is going like this if you draw a circle. So this is a positive moment. Then we are done with that. Let's take this one, 600 sine 45. I draw a perpendicular line from B again to the line of action of the force. So the length of this perpendicular line, that will be 5 meters. So we can say 600 sine 45 times 5. So is it a clockwise or counterclockwise again about B?
It's counterclockwise.
Counterclockwise, going like this. About, if you draw a circle about B, that will be going like this. So it is again a positive moment. Now, let's get rid of all these unnecessary lines. Now this one. Now this one, if I'm extending the line of action of the force of this 600 cos 45. 600 cos 45. If you draw a perpendicular line, that will be this small distance. Do you agree? That is the half of the thickness of the beam. They have given us the thickness of the beam. In some situations, they are asking us to ignore the thickness of the beam. But if the thickness of the beam is given to us, we need to consider that thickness. So you can see this 600 cos 45 is not going through B. It has a small deviation from B, which is 0.2, which is your perpendicular distance from B. So you can say this one is 600 cos 45 times 0.2. Is it making a clockwise or counterclockwise moment now? The arrow is this direction, see? So if you draw a circle, it's going like this. So it's a clockwise, so it is negative. Agree? Any question? Now we have one more one, which is AY. AY perpendicular distance is 3, 4, 5, 6. Oh, sorry, 3, 4, 5, 6, 7. 7, and it is making a clockwise moment, so negative. So that when you add all these together, it will be 0. It should be 0. So we are going to add them. So we have 200. 100 times 2 is 200 plus 600 sine 45 times 5. So we can put the numbers in the calculator. So 600 sine 45 times 5, which is 2121.3. I'll just ignore the 0.3, okay? So the next one is a negative 600 cos 45 times 0.2. So 600 cos 45 times 0.2. So that will be 85. Just I rounded up. And minus AY times 7 is equals to 0. So this is what I got. Now AY is a negative, so I can take it to the other side. I can say 7AY is equals to, now we can add all together. 200 plus 2121 minus 85, which is 2236. So now we can solve AY is equals to 2236 over 7. So AY we can find, which is 319 newtons. Is it clear or not? I told you, I think in the first week, everything is connected. So week 1, week 2, week is needed for the week 3. We are still in 3rd week. If you have missed week 1, 2, and 3, before we go to next week, please catch up. And if you have any question, let me know, because otherwise it's not easy to understand. When we go further, if you need to know, maybe when you are in week 7, you need to know the week all 5 weeks. Otherwise, you don't understand week 6. So I try my best to explain as much as simple, but I may not be able to help you when we are in week 8. I may not be able to again revise the first 7 weeks. So I want you to catch up everything. And if you have any question, just ask. If we need to have a small Zoom meeting and sort it out, we can do that as well. So please, if you don't understand, that means you don't know how to take moments. I think forces are fine with you dividing, but moment is something that you need to practice, finding moments. So are you guys okay, or do you want me to go through again and show you how to find moments?
I mean, I'm all right.
Don't worry. So we still have time. We'll do a few more questions. Okay. So AY we found AY we found 319. So let's say AY we found. AY is 319 newtons. This is AY. We have, so this is it. So we have 2 more forces to find, By and Bx. Now we apply the moment equation. Now we need to apply the other 2 equations. All the forces in the x direction should be equals to 0. So what are the x direction forces we have? We have Bx, and also we have this component, which is 600 cos 45. So we have two x direction forces. When you write them, all are towards the positive x. So you can write it as positive 600 cos 45 plus bx is equals to 0. So you can find the bx, make the bx the subject, and that will be negative 600 cos 45. So you can find bx as well. Just put the numbers in the calculator. 600 cos 45, which is bx is equals to negative 224 point something. Okay, I just write the whole number. So this negative is okay, because that means we assumed a force towards the positive x direction, but the real reaction force is opposite. That doesn't matter. So we found the direction. When we solve it, we find the magnitude and also the direction correctly. Now, if you consider the forces in the y direction, can you find me the y direction forces, please? So what are the y direction forces we have? We have AY. We have AY positive upward arrow, negative 100, because this arrow is downward, positive BY, arrow is upward, negative 600, sine 45, arrow is down. So that is equals to 0. AY is known, which is 319 minus 100 plus BY minus 600 sine 45 is equals to 0. Now, the only unknown in this one is BY, so you can find BY. If you make the BY the subject, you will be able to find the BY. So, if you make the BY subject, you have 600 sine 45 plus 100 minus 319. So this will be the answer for BY. Let's put that in the equation. 600 sin 45 plus 100 minus 390. So that is 205. 205. So BY is 205 and this one is negative 224. We solved everything. We found everything. So what are the three unknowns? So they are asking us to find the three unknowns. So we found the three unknowns, which is this one, and this one. We apply the conditions of equilibrium and we found them. Are we good?
Yep.
Okay, can I give you a few minutes to solve this one, please? Here, you don't need to consider the thickness of the bead, 0. The thickness is ignored. I'll give you a few minutes. Think about, there are two supports. Which one is A, which one is B? Let me see whether I have. Yes, this one, this one, this one. Do this. You try, I'll give you a few minutes and I will do. First thing is identify support. So A, you have a pin, that means two unknowns. B, you have a roller, which is one unknown. So these are the unknown forces. Now we need to apply equilibrium conditions and find the unknown, three unknowns. But before that, you may need to do this one, divide this one like this. Do you remember how to divide this 2,500?
Yeah, the X direction is 1500 and the Y is 4000, 2000.
Yes, so how did we do that? In the Y direction, you can find this theta if you want to. I told you that day, you can find theta, you can write tan theta, and you can write opposite over the adjacent, and you can find the theta, and you can use cos sine. But there is an easy way, I explained you. So if you want to do that, you can do, this is the Y direction component 4. So 4 divided by the hypotenuse, which is 5. So that will be your y. When you come to x, x is 3. So 3 divided by 5 will be the x direction. So you can say 1,500 in the 1,500 in the x direction, and the y direction will be 5 times 2,000. So you can easily do it. Otherwise, you can find the theta and do it as well. So these are the two forces you can ignore. You can ignore this one now. Up to here, any question? Now let's consider moment is the easy way, okay? If you use the moment equation first, that will be easy. But like, you know, if you get confused, let's consider all the forces in x direction. What are the forces in x direction? We have AX positive because positive arrow is positive x. And also we have 1,500 again positive. Is this 900? What is it? This 900 Newton meters is what is that? Is it a force? What's that? Other forces are in the y direction, so we don't consider this AY 2000 and this BY are in the y direction. So it's not coming to the x forces. They are perpendicular. I'm just asking, what is this 900? Then do we need to consider any force from 900? What is this 900? Is it a force or a moment? It's a couple moment, am I right? It's a couple moment. Couple moment is where you have forces, there is no force. It's just a moment. So you don't need to consider this 900 for any force equations. This is only come for your moment equations. It is just a couple moment. Okay, so this one is not coming to your any force equation. So this is your first equation. So you can find AX, which is negative 1,500 Newton. So that's found. Easy. If you want to find the y direction forces now, you can find the y direction. What are the forces in the y direction? AY positive, BY positive, minus 2,000, arrow is down. That will be equals to 0. So this is your y direction forces, but you have two on. So you need to take the moment to find one first. So now you can take the moment. You can take the moment about A because A is easy. You don't get these two in your equation. Two forces are going through A. And also if you extend the line of action of the 1,500, as we are ignoring the thickness of the beam, this also not making any moments because it's going through the point where we are taking the moment about. Am I right? So we need to consider only three things: 2,000 Newton force, By, and the 900 Newton meter moment. So now if you write this, 2,000, if you extend the line of action of the force and if you draw the perpendicular line, the perpendicular distance is 1.5. So we can say 2,000 times 1.5, and it's going in the clockwise direction, it is negative. And By is going in the counterclockwise direction, and the perpendicular distance is 3. So positive 3 times By. And 900 is, I need to times by this 4.5 meters. So is it 900 times 4.5 meters, or it is just 900? What it is?
That's just 900.
Just 900. It is a couple moment. You can even see the the units. It's already a moment. You don't need to times by a perpendicular distance. It's already a moment. So the forces we multiply by the total, perpendicular distance to make it to a moment. Find the moment created by the force. This is the couple moment. So you need to minus this 900 because this 900 is in the clockwise direction. Now, if you make this to 0, you can find By. So when you find the By, you can use that By here, and you can find the Ay as well. So can you please find me? I'll give you a few minutes. You do the equations by yourself and find the two things, and I will check the answers. Ax is already found. Did you find the numbers I found, and I got these numbers, but if you get different numbers, tell me. I may be wrong. Did you get the same numbers, or difficult or different, or do you want me to do it again? Okay, so where we got it. So how about others? Anyone else got the same answers? No one else got the same answers? So Lachlan, Phil, and Scott left. So Lachlan and Phil, are you guys okay? Do you get the same answers?
Yeah, I did.
Okay. So I think that this is right now. So we were doing the tutorial questions. I don't want to proceed with the tutorial questions. We'll do on Thursday. So let's go back to the lecture. I think you are now a bit familiar with what we are doing. So we'll end this. Just go back to the. Okay, so now you actually, when you have this also need to be done when you found the AY and AX. When you find this, you need to find the resultant of this one as well. You already know how to find the resultant because AX is this, AY is this, so the resultant will be like this. So you can find the resultant without keeping AY and AX separately as two forces. You can find the resultant force and the direction of the resultant force at A when you have a pin. So we normally don't keep as two components. We add them together and we make it to a single force when we give the answers. So here, this question you can do now. There are a few questions. We'll do more questions in the so we'll do more questions after completing the rest of the theory. So here we can't, there are some, you only can solve with your knowledge, you only can solve statistically determinate questions. So like this, if you have only 3 unknowns, you can solve them only if there are only 3 unknowns. There are some situations where you can't do, you get more than 3 unknowns. In your syllabus, you are not going to do this kind of problems, but they exist and you can do it in different methods, finite element method. And if you do mechanics later on in a degree or a master's or bachelor's or anything, you will learn how to solve statistically indeterminate questions as well. But in your syllabus, you only have 3 unknowns. So with 3 equations. So this equation and this equation and the moment equation. With 3 equations, you can solve and find the 3 unknowns. So you only get statistically determinate questions. Okay, so I think that's all we have. So as we have time, we'll do some questions. One question I want you to try by yourself. Okay, I'll give you a few minutes here. We have time. Take your time, think and do step by step. I will see how you go. First thing that you need to do is identify the support reaction. So I don't help you. You try and then I will see how you go. Identify the support. So you have a support here. Find out whether it is a fixed support, roller support, or pin support. Depending on the support, you put the forces. Roller support means 1 unknown, pin support 2 unknowns, fixed support 3 unknowns. Identify the support and then draw the free body diagram. And third one is apply the equilibrium conditions and find these unknown forces. So I'll give you a few minutes and then I will do. If you do this, you have understood the whole week 1, 2, and 3, all 3. You can be happy. Before you proceed, can I know what kind of a support we have at A?
Fixed
Fixed support. So how many unknowns?
3.
3 unknowns. That's true. You can have unknowns like this. Okay, so you drew the Hilbert diagram like this, and this 400 may need to divide into 2 components because it is not in the horizontal and vertical. So we have to divide that into 2 components. Have you done that?
Yes.
So let me check whether, so let me see. Do you get this one as 400 what? Cosine.
Cos.
Cos, that's right. And this one is sine. Okay, so you don't have this one. Now you can consider all the forces in x direction. We only have 2 forces, which are AX and 400 cos 30. So you can find AX. Is that what you got?
Yes.
It's good. How about you, Aiden? Okay. It's good. Now you can consider the y direction forces or take the moment, because y direction forces, you have 2 unknowns, however. No, y one unknown. It should be fine, yes, 1 unknown. You can consider y direction forces. So we have AY positive minus 200, so it's altogether 600. Minus 400 sine 30 is equals to 0. So you can find AY, which is 600 plus 400 sine 30. So we get as 346.4 newtons, and this one has 600 plus 400 sine 30. This is 800 newtons. Up to here, are we all on the same page?
All good.
Okay, that's good. Now the moment. Moment. Don't be scared with the moment. You just need the right distances. So these 3 meters are given to us, and this is 60 degrees. So this distance is 3 cos 60, and this distance is 3 sine 60. It's not hard. Now, if you take the moment about a counterclockwise positive, take one at a time. So if you consider this 400 cos 30, and if you draw the line of action of the force, perpendicular distance is what? You are drawing the perpendicular distance from A to the line of action of the force. So that will be
3 sine 60.
Yes. And is it a clockwise moment or a counterclockwise?
Clockwise.
And all of these ones are making clockwise, because if you see, they all line of action of the force. If you consider them, they will be like going in the clockwise. So all negative. So MA also negative. So I didn't write the MA. MA minus 400 cos 30 times 3 sine 30. Now we have all the other ones also negative. So one by one. Let's take the first 200. The perpendicular distance will be 1 plus 3 cos 60. Do you agree with me? So this 1 plus these 3 cos 60 should be there. And if you go to the next one, next 200 will be 2 plus 3 cos 60. Next one, you can add them together, or else you can take separately. You can consider 200 plus 400 sine 30 together, or else you can do it separately. It's okay, it's up to you. So 200, 3 plus 3 cos 60, then we have another 400 sine 30 times 3 plus 3 cos 60. So these all should be equals to 0. So in this one, it's a long equation because we have a lot of forces, but the only unknown is MA. So you can make the MA subject. You can make the MA subject and find MA. So when you find it, let me know. Aiden, are you okay? When you find MA, let me know. I have the answer, so we can check whether we are right or wrong. So how about you, Phil? How far you went? Did you find the MA?
No, no.
Okay.
Is it somewhere like 3,700 Newton meters?
Let me see what I.
No,
Is,
I've missed 200 somewhere.
is this right or wrong? I'm not. Maybe I have done it some times ago. So, Aiden, did you get this so different?
No, I'm like 200 short.
So how about you, Aiden? Did you get these numbers? Okay, I'll check this my one as well. So 200, all negative, yes, that's right, all negative. So 200 times 2. It is 2.6, I think. 3 sine 63 sine 60 means 2.6. This is 2.6. 6. Two point six. 200 times 363 cross 60. 1.5, that is right. So it is 1.5 plus 2.5. Yes, this is 2.5. Yeah, I am wrong. You guys should be right. No, this is no, I think yeah, I am right. I think this is 5, this is 3.5. The ones we had was right. 3.5 for 4.5. Yeah, I have missed one here. Yes. So that is 320. 4.5. Yes, 36. So yes, I am now it's all okay. It should be 3,900 if this is 200 times 2.5 plus 200 times 3.5 plus 400 times 4.5 plus 346 times 2.6. Yes, 3,899.6. So that's why I have put it as 3,900. Do you get it or not? Because this is 1.5. So in every 200, I have added 2.5 because this is 1 plus 2, 1.5. This is 3.5 and this is 4.5. 400 came because when we divide, this is 200 and this is 200. So I added both together. That's how the 400 came. And this horizontal force, that one is 346. That is 400 cos 30 times 2.6. That is this one. So everything is here. So I think this answer should be right, which is 3,900. Do you get it or not? Maybe small decimal errors can be there, but 2,646. How come? So do you see anything wrong in my one, Aiden? Okay, 400 I got because this one and this one acting at the same point. So I have added those two, 400 sine 30 and 200 I have added both together because it's acting at the same point. That's how the 400 came. Or else you can write it in two 200s. Is it clear or not? The horizontal one, okay. Yeah. So how about you, Phil, do you still get different answer? Or
Yeah, I got, and I've got all the components, and as far as I can tell, they're correct. But when I'm adding them up, they don't add up.
to 3,900, it's not 3,900.
No, not when I do it, but I think it's a new calculator. I don't know.
I added again, still I get 3,000. This was done some times ago, maybe a few years ago, but I redid it. So I still get 3,900. I'll check again. Okay, so Aiden got 3,800, 3,900 as well. So Phil, will you just check again, please? So yeah. Do you still get different answer? What do you get, Phil?
Yeah, no, sorry, I found it.
You get the same?
Yeah. No, I found where the error is.
Okay, that's good. Now we are done with MA and we already found these two. So we are fine with this. Okay, now we haven't finished. Now we need to do the last part. Last part is when you have these two, you need to make it to a single force. AX is opposite negative, so that means it is in this direction. So it's in this direction, it's in the opposite direction, this way. It is 346 this way. And this is 800 upward. Now you need to find, it should be shorter. We need to find this 356. Start to end, we need to find this resultant. So what is the resultant? You use the Pythagoras theorem to find the resultant, which is 800 squared plus 346 squared square root of this. So when you put that, you already done this in week 1. I hope you're okay. Plus 346 square root of the answer, that will be 871.6 newtons. And magnitude is not enough. We need to find the direction, which is this theta. So tan theta is opposite, which is 800 over 346. So if you take the tan inverse, 800 divided by 346, which is 66 degrees. So 66.6 something or else 66:36 minutes. So we can say 66.6. Decrease the angle. Are you okay with finding? I hope you are okay because you did that in the week. So are you okay with finding this resultant and the direction of the resultant?
Yep.
Okay, now if you put everything together, I have already. This is wrong. This is wrong. Answer is wrong because direction is this way. Am I right? This angle is 66.6 degrees. So our answer should be like this, 872 is that what you got? Yes, roughly 872 newtons. Yes, so are we all okay? So this 872, we know how we got it, and this 66.6 also we know how we got it. The only error I have here is this direction because I have done something wrong there. So rest is okay. Okay, so okay, so that's good. So this is summarizing all 3 weeks, and you have a lot of questions. If you do one question from this section, it will summarize everything. So there are more questions. We'll do next day, and also you can try now or any question, you can do any question. So you can do this one as well if you want to. You can try this one by yourself. We did it halfway, but we didn't finish it. You can do this one, and also we'll do more questions on Thursday. Yeah, do you guys have any other questions? In
No.
that case, we'll okay, that's good. Okay, I'll wind up the class because I have another class at 7:30 as well, and I'll see you on Thursday. Okay.
See you then. Thank you.